I have a rational function to graph here. I want to state the domain, any holes, vertical asymptotes, horizontal asymptotes, zeros, and the y-intercept. All right, so the first thing you want to do whenever you're dealing with a rational function is factor everything that you can factor. So my numerator is going to, I can pull a 2 out, and I'll be left with x squared plus 5x plus 6 over x squared plus 3x plus 2. And then I can factor further, and I'm going to have 2 times x plus 3, x plus 2 over x plus 2, x plus 1. So my x plus 2's are going to cancel. I've got 1 on the top, 1 on the bottom. So this simplifies to 2x plus 3 over x plus 1. Only thing, though, is I can't put a -2 in there, right? Because -2 is not in the domain of the original function. So if I try to put a -2 in, I would get well, let's first just graph this thing, and then we'll take the hole out later. So we have a hole. Anytime you have 2 common factors on the top and the bottom, you set that equal to 0, and that gives you the location of a hole in the graph. Okay, so we'll just keep that in mind. We have a hole in the graph at x equals -2. To figure out the y value of that hole, you plug -2 into the reduced version of the function. So if I put a -2 in there, then I get 2 over -1. Yeah, -2 plus 3 is 1, times 2 is 2, so my numerator is 2, and -2 plus 1 is -2. Hole in the graph at -2, -2. Okay, and then I can get a vertical asymptote. Vertical asymptotes happen, take the remaining denominator factor, the remaining factor in the denominator, the one that hasn't been canceled. We set that equal to 0 and solve it. And there's my vertical asymptote. Horizontal asymptote, I have to compare the degree of the numerator and the denominator. Since they are the same in this case, the asymptote is at y equals 2 over 1, the ratio of leading coefficients. So y equals 2 is my horizontal asymptote. There are other rules for horizontal asymptotes for when the degree of the numerator is smaller and when the degree of the numerator is bigger than the degree of the denominator. So if you don't know those, you should look those up. And I think I have enough to, I should get y-intercept and zeros. Let's get the y-intercept and the zeros. So to find the y-intercept, we just plug in 0. I move 0 into my original function. So it's going to be 12 over 2, which is 6. So I've got a y-intercept at 6. And then for x-intercepts, set the reduced numerator equal to 0 and solve. And we get x equals -3. So there's our x-intercept, there's our y-intercept. Now I can graph everything. So my vertical asymptote is at x equals -1. Horizontal asymptote at y equals 2. X-intercept at x equals -3. And a y-intercept at 6. And then I know my end behavior. And I think that, and -2, -2 is a hole in the graph. So I'll put a hole there. And then I just follow my asymptotes as guidelines. So my function has to go something like this. And it'll approach the horizontal asymptote in the end behavior. So this goes like that. And that probably goes like that.